Look at it. That is not an ordinary photograph. No camera took that image. No lens, no shutter, no single moment of light hitting glass. For a century, we said this was the one thing that could never be seen. A black hole eats light. It gives nothing back. Photographing one is like photographing an absence. We saw it anyway. We did it by turning an array of telescopes into a single eye the size of a planet to catch a ghost about 55 million light-years away. And then, the week the world finally saw it, we turned on each other over who deserved the credit. But here's where nobody tells you about that famous orange ring. It's not the black hole. It is hot plasma swirling near the event horizon. Its light bent and wrapped around the darkness by gravity so violent, it curves the path of light itself into a circle. Matter shredded and burning as it spirals toward a hole in reality it will never climb back out of. And it was not captured. It was reconstructed, pulled out of radio static by an instrument the size of a planet. This is how we photographed the thing that swallows photographs. Let's start with why this should have failed. Black holes do not shine, they do not reflect, they do not glow. Once light crosses the event horizon, it is gone forever, and nothing that goes in ever comes back out to tell you what happened. So nobody was ever trying to photograph the black hole. But a black hole leaves a mark on everything around it. They were hunting the shadow, the dark bite it carves out of the burning gas swirling at its edge. And that shadow is small, not small like a coin, small like this. From Earth, the ring around M87 spans roughly 40 micro-arc-seconds across the sky. That is a donut sitting on the surface of the moon. Hubble can see the galaxy M87. It can even see the vast jet blasting out of its core. But point it at the black hole shadow and the detail vanishes. Thousands of times too small for even Hubble to resolve. A blur where the most important object in the frame should be. The mathematics give one answer, and the answer was absurd. To resolve that shadow, you would need a telescope the width of the Earth. Nobody can build that. Long before humanity built a telescope the size of the Earth, one man had already seen the black hole. Not through a telescope, through mathematics. In 1979, French astrophysicist Jean-Pierre Luminet asked a question no one had ever answered. If nobody can see a black hole, what would one actually look like? At the time, no computer could simply generate the answer. Luminet fed Einstein's equations into an IBM computer using stacks of punch cards. The machine calculated how light would bend around an invisible object so massive that it warped space itself. Then something extraordinary happened. The computer didn't create a picture. It produced numbers, thousands of them. So Luminet plotted every point by hand, slowly turning mathematics into the first realistic image of a black hole ever created. Most people imagined a black hole as a simple black circle. His drawing showed something very different. A glowing ring of light wrapped around darkness itself. An image so strange that, for decades, nobody knew whether nature would ever allow it to exist. 40 years later, humanity finally looked at a real black hole, and when scientists compared it to Luminet's drawing, they realized something extraordinary. He had been astonishingly close. Luminet had shown us what we should see. Now we needed a way to see it. Nobody could build a telescope the width of the Earth, so they built one anyway. If you cannot make one instrument the size of a planet, you take the instruments already scattered across the planet and force them to lie. You make separate telescopes believe they are one. Hawaii, Chile, Spain, Mexico, Arizona. Several stations across the globe locking onto the same black hole during the same observing windows, riding the same spinning rock. The wider 2017 campaign reached even farther south, to a station at the South Pole, but M87 never rose into its sky. That was the Event Horizon Telescope. more than a decade of upgrades, engineering, and coordination before it ever opened its eye. Together, they formed a virtual telescope the size of a planet. Earth's own rotation dragged those dishes through space like fingers across a surface, filling the gaps between them. And every wave that arrived had to be stamped with its exact arrival time by hydrogen maser atomic clocks, among the most precise instruments ever built by human hands. Miss by a fraction of a second, and the whole planet-sized telescope goes blind. But it worked. Scattered dishes became one machine, resolving detail roughly 4,000 times finer than Hubble could manage, and it still could not take a picture. There was never going to be a picture. Every observatory recorded static, faint radio hiss arriving from a galaxy about 55 million light-years away, meaningless on its own, separate mountains of noise, one at every participating station. Petabytes of it, far more data than could ever crawl through the internet, so much that the fastest way to move it across the world was to load it onto an aircraft and fly it. Hundreds of hard drives shipped as cargo to processing centers in Massachusetts and Germany. The most advanced observation in human history, boxed up and freighted like parcels, because no cable on Earth could carry it fast enough. And even after every drive arrived, there was still no image. Only synchronized measurements and noise, waiting for someone to prove that a shape was hidden inside them. They had mountains of data. They had no picture. Turning that noise into a picture would fall to a handful of people who had never pointed a telescope at anything. And one of them was about to become the most famous and most attacked base of the whole project. Here is the part that should not have worked. You cannot photograph what you did not fully record. What they had was a jigsaw with most of the pieces missing, scattered radio measurements with vast empty darkness between them. An infinite number of different images could explain that data. Only one of them was real. Some of the people who could help crack it were not astronomers at all. They were computer scientists, and one of them was Katie Bowman, then a graduate student at MIT, young enough that this problem would swallow years of her life before it ever gave anything back. And she helped build the imaging tools that would turn scattered signal into something a human eye could read. She described the challenge like this: photographing a grapefruit sitting on the surface of the moon. One of her early algorithms was called CHIRP. It explored how careful assumptions could fill the gaps in sparse data without hardwiring a ring into the answer. But CHIRP was never a magic button, and no single algorithm produced the final image. The collaboration pitted independent pipelines against each other, established methods and newer ones alike, to see which features survived them all. Because the real danger was never that they would see nothing. The danger was that they would see exactly what they hoped to see. An algorithm that expects a ring can coax a ring out of pure static. Give 1,000 people the same fog and they will all draw the same face in it. So nobody trusted a single method alone. Not the algorithm, not each other, not themselves. The collaboration did something almost no scientific project does. It split into 4 teams, handed each the same mountain of noise, sealed them off completely, and told them to build a picture using different families of techniques. No comparing notes, no progress updates. 4 groups working in the dark for weeks, each blind to whatever was emerging on the other 3 sets of screens. But 4 teams working blind can only end 2 ways. Either 4 different pictures and a decade of work collapses into nothing, or 1. Then they opened the door. 4 independent reconstructions, and on every single screen, the same bright ring, the same dark center, the same shape. Nobody had imagined it into being. It had been sitting inside the data the whole time, waiting for people careful enough to find it and honest enough not to fake it. Then the world saw it. On April 10th, 2019, 6 simultaneous press conferences around the world, timed to the same moment. 1 image, a ring of fire around a hole in space-time. M87, more than 6 billion times the mass of our sun. An object so heavy, it bends the path of light itself into a circle. Einstein published the equations behind all of this in 1915. He questioned whether nature would ever really allow objects this extreme to form. More than a century later, humanity looked straight at one, and the shadow matched what the mathematics predicted with astonishing precision. But there is a second image tied to this story. Katie Bowman at a laptop, hands pressed over her mouth, watching the shape finally resolve on a screen. A moment caught during the reconstruction that raced around the world when the picture was finally released. That photo went viral in hours. Then the world took it back. Within days, the posts started. Bowman had been overhyped. Bowman had barely contributed. The real work, the posts claimed, belonged to a colleague, Andrew Kale, who had written most of the code. But Kale had never made that claim, and he did not want it. He refuted it himself, publicly, immediately. He said the effort to pit them against each other misrepresented what both of them had actually done. 200 people, 60 institutions, 10 years, there was no single author to crown and none to dethrone. It changed nothing. The story had already outrun the truth. Humanity built a telescope out of a planet, dragged an image out of pure static, reached the edge of reality itself, and then spent the following week arguing about whose name went on it. Look at that ring one more time. That light left M87 about 55 million years ago. There were no humans then, no cities, no words, nothing on this planet that could look up and wonder what it was seeing. It crossed the void for about 55 million years to reach a handful of dishes on a small wet rock, and it took 200 people across 60 institutions to turn it into something a human eye could see. Not one camera, not one algorithm, not one genius. An entire planet working as a single instrument to see the one thing that was never supposed to be visible. The black hole does not know. It does not care whose name went on the code. It will keep feeding for as long as matter reaches it. Gas will spiral in, collide, flare, and vanish past the edge forever. The glow around the shadow shifting and churning, never quite the same picture twice. Long after this argument is forgotten, long after every institution that funded it has crumbled into dust, long after our own sun swells into a red giant and leaves the earth burned beyond recognition, that dark shape will still be there, wrapped in fire, doing exactly what it does now. We built a planet-sized eye and pointed it at the thing that erases everything. And for one moment, it looked back.